Alright, so we're continuing with radicals, so simplifying radicals, 26c. So here we are looking at the fifth root of negative 2, 4, 3 y to the fifth. Well, of course, this is odd and this is odd, so there's nothing to worry about concerning absolute value. All right, so this is just going to basically be you trying to find out what the fifth root of negative 243 is, which I believe, let me see, fifth root of negative 243. 3 times 3, that should be 3, right? Right, let's just check. 3 squared is 9. 9 times 3 is 27. 27 times 3 is 81. 81 times 3 is 243. All right. So this is going to be negative 3. And then the fifth root of y to the fifth is just going to be y. All right, so what we're noticing here again, like I said, if all things work out properly, if n is odd, right? So if n is odd, this is just going to be equal to a. So the reason for this is we talked about the odd root being 1 to 1. All right, that kind of function. We have if you had odd power rather, then that would be a 1 to 1 function. Anyway, so if n is odd, then the nth root of a to the n is just a. If n is even, right, then this has to be in parentheses. All right, and that's going to be equal to the absolute value of a, and in this case is even. Okay, so this is what happened. Those are the two cases that we have to think about. So in this case here, n was odd, 5, n was odd, and so it works out to be this. We don't need the absolute value. You should not have the absolute value if n is odd. Odd, odd, same number, using these principles. All right. Okay. 26d. So you have the fourth root of 625 x plus 3 to the fourth power. Again, and now this is just going to be, let me just make this a little simpler than the other ones. You can split across radical signs, all right? So you can split, so it's going to be 4th root of 625 times the 4th root of x plus 3 to the 4. And the 4th root of 625, I think that's going to be 5. 5 times 5 is 25. 5 times and 5 to the 3 is 1. So this is going to be 5 definitely. And then this here is just going to be the absolute value of x plus 3. So it's going to be 5 times the absolute value of x plus 3. Now I want to just note something here, right? So we just want to add a note here. Add a note, the problem is done. We got the answer. If A, B, C, I want to go all the way up to Z. All right? I think that's all you need. All the way up to Z. If these are non-negative, right? So A, B, C, D, E, F, G, H, I, all the way up to Z. I just want to make something real big here. If these are non-negatives, then the nth root, doesn't matter what we have here, nth root of A times B times C all the way up times Z, right? That is just going to be the nth root of A times the nth root of B times the nth root of C times, and so on, the nth root of Z. Doesn't matter how many of them you have. I can go on to 100 and even much more. But the point I'm making here is you can split the radicals like this, right? You can split them like this across multiplication. That's the whole idea, okay? And obviously, we want, in this case, we want the A, B, C, and all the way up to Z, each of these things to be non-negative. If they are, if n is odd, then you don't have to worry about them being non-negative, all right? N is odd, it's a different case. So let me just write it out explicitly. If you're watching the video, if n is odd, then this here, all right, to the nth root of some A, B, C, I'm gonna go all the way up to Z, doesn't matter what it is, how many of them we have. But the point is, if n is odd, doesn't matter what A, B, C, and D are in signs. That will just be the nth root of A times the nth root of B times the nth root of C times the nth root of Z. If n is odd, right, it doesn't matter regardless of the sign of any of the A, B, C. Right, so if n is odd, it doesn't matter. That's the point I'm making. If n is, however, even, then you kind of want to actually let A, B, C all the way up to Z or whatever, or wherever you're in, you want to let those actually be non-negative, right? Otherwise, you're going to run into trouble for a real number answer, that is.